Good morning, dear students. As we all know that most of the physical and chemical changes are accompanied by changes in various forms of energies like heat, light, work, electricity, etc. And all these different forms of energies are interconvertible into each other and hence they are related to each other. So now we are going to start a new chapter, Thermodynamics, which deals with all kind of relationship between different forms of energies. So dear student, thermodynamics is a branch of science that deals with relationship, a kind of quantitative relationship between heat and other forms of energy. And actually in chemistry, our study confines to chemical changes and chemical substances only. So this restricted branch of thermodynamics dealing with all chemical changes and energy changes associated with them come under chemical thermodynamics. And actually chemical thermodynamics lies its importance in some facts, like it helps us to predict whether a given chemical reaction can occur or not. Means if a particular reaction will be carried out at a particular condition, then that conditions, what will be those conditions that can be predicted by using the field of thermodynamics as well. And also it helps to predict the extent of reaction before the equilibrium is attained. Equilibrium is a state where the forward and backward reaction rate becomes equal. So at that time the process is difficult to proceed further. So when this equilibrium will be attained, this can be predicted by using the knowledge of thermodynamics, and it also helps to deduce some important laws which we will discuss later in other chapters. So with this we are going to start with this new topic. First of all, before going into the details of thermodynamics, I just want to introduce few terms or basic terminology used in thermodynamics. As this is entirely a new chapter for you, so you must know about these different important terms which we will use in chapter. So first of all, the basic term used for any thermodynamic process is system and surroundings. System is actually the part of universe. Actually, whenever a physical or a chemical change takes place, the energy changes are taking place in that particular region in which the process or where the process is carried out. The entire universe is not at all affected by the changes taking place in a particular system. So therefore, we consider a part of universe to study a change, physical or chemical or the various kind of energy changes taking place there. So that selected part of universe for considering the study of thermodynamic process is known as system, and the rest of the entire part of universe, which is actually, you can say, present around these system, is called surroundings. And thermodynamic system and surroundings are separated by an envelope called the boundary of the system. It may be imaginary or it may be walls of a container if you are carrying out a particular chemical reaction in a vessel. And the system and surroundings together form the entire universe. On the basis of exchanges taking place between system and the surroundings in a thermodynamic process, actually system and surroundings can exchange matter and energy, either one of them or both of them or none of them. So on the basis of that, there are three types of systems in thermodynamics. First of all, open system. An open system is a thermodynamic system in which system and surroundings can exchange both mass as well as energy. And a kind of system in which only energy can be exchanged but mass cannot be exchanged, means we cannot add or remove matter from the system. In that case, it is said to be a closed system. And third type of systems which can neither exchange mass or nor energy, then it is said to be an isolated system. Define these systems with the help of certain examples. Open system, as it can exchange both matter as well as energy, means it is a kind of open process carrying out in nature as well. Actually, all processes taking place in nature which do not are bound in particular boundaries, so they are said to be open systems. For example, living bodies, animal and plant bodies, are also kind of open system because we can exchange energies as well as matter with the surroundings. And also you can consider a chemical reaction taking place in a open vessel or open beaker. The vapors or the matter can be exchanged within the surroundings, as well as energy can also be exchanged. A closed system is a kind of system which can exchange only energy but not matter. So here we can consider an example of a closed metallic container. Closed container cannot exchange matter, means if vapors are produced in a particular chemical reaction, so they will be inside the container only. But as the container is of metallic walls, so metal being a good conductor of heat, exchange of energy can take place within the surrounding and the system. Hence, this kind of systems are called to be closed systems. And third kind of systems having insulated walls. Insulated walls are the walls which do not allow energy to transfer from system to surroundings or vice versa. Hence, these kind of systems can neither exchange matter nor energy. Here you can consider one example of thermos flask. So you can see here some examples of isolated, open and closed systems. Next is thermodynamic properties. So now there are certain physical quantities which are used to define, or you can say to describe a particular thermodynamic process and its state. So these are called thermodynamic properties, and these properties are of two types. First of all, intensive properties. Intensive properties are those properties or those physical quantities that are independent of the quantity of matter in a system. एक system में कितनी quantity में matter present है उस पे depend नहीं करती है properties. These are independent of the quantity and basically they are dependent on the nature of the type of matter present in the system. And these properties are temperature, pressure, density, etc. Actually, we can take a simple example. If you have 1 liter water in a container, and in second container you have 2 liters of water, and if you both of the containers are kept at the room temperature, no external heat is supplied to them, and if you read the temperature and measure the pressure in both of them, then the readings will be same in both of the cases. Means temperature and pressure and densities are these kind of properties which do not depend on the amount of the substance present in a system. So these are intensive properties. Next type of properties which are dependent on the amount of the substance or the quantity of the matter present in the system, means system का size कितना है उस पे अगर ये depend करती हैं, then they are said to be extensive properties. Extensive properties, there are basically 7 extensive properties which are used in thermodynamics: mass, volume, heat capacity, internal energy, enthalpy, entropy and free energy. All these are important extensive properties of any thermodynamic system that depend on the amount of matter. कितना size है system का, कितना उसमें matter है, उस पे ये depend करेंगी. Next is state function. Actually, a thermodynamic process can be, you can say, identified when a change occurs from initial state to final state. मतलब एक प्रोसेस तब होता है जब एक सिस्टम अपनी इनिशियल स्टेट से फाइनल स्टेट में जाता है, और एक पर्टिकुलर स्टेट को हम डिफाइन कर सकते हैं बाय यूजिंग सर्टेन प्रॉपर्टीज. And these thermodynamic properties, which we have already discussed in the form of intensive and extensive properties, if they depend only on the initial and final state of a system, and they are independent on the path followed to change the state, then they are said to be state function. For example, if a system is initially at a state first or state 1 where the temperature is T1, volume is V1, pressure is P1, and if we are carrying out a change in 2 or more different ways to increase the temperature up to T2, volume up to V2, then the temperature and volume will only depend on the final and initial state. आप उस change को किस path से कर रहे हो? If you are following 2 or 3 different ways, suppose to increase the temperature, if you are supplying heat to the system, or if you are doing some mechanical work on the system, but if you want to increase the temperature from T1 to T2, then this temperature will depend only on the initial and final system. It will not depend on how you have carried out that particular change. आपको तो वो final temperature मिल गया, अब वो कैसे भी आया इस पे temperature की value depend नहीं करेगी. तो all these properties, thermodynamic properties, which are independent on the path followed to carry out a change, initial to final, आप कैसे पहुंचे उस पर डिपेंड नहीं करता, then those properties are called state functions. And all those properties which are dependent on the path, they are called path functions. So these properties which are actually state function in thermodynamics are temperature, pressure, volume, internal energy, enthalpy, entropy, and free energy. All these properties are state function because they have a fixed value at initial and final state, independent of the path followed by or path which is followed to carry out that particular change. And two important thermodynamic properties which are path dependent, mean जो path पे depend करती हैं, heat and work. Suppose work done is always dependent on the path. If you are carrying out a different path, then work done obviously will be different. If you are moving upstairs or you have to go to higher floor of a building, and if you are going through a lift or you are taking staircase, in both of the cases ultimately so you will reach up to the highest top floor, but work done by you will be different obviously if you are going through lift or if you are going through stairs. So heat and work are two such physical quantities which are dependent on the path. So these are called path functions, and other properties written towards right side are all state functions. Next is thermodynamic process. Actually, thermodynamic process is said to occur when a system changes from one state to another state, or you can say when you observe a change in any of these observable properties of the system which we have discussed. If temperature, like temperature, pressure, volume, enthalpy, entropy, if any of these observable property of a system changes, then a thermodynamic process is said to occur. Thermodynamic processes may be of 4 types on the basis of a particular property which remains constant for that particular process. So first of all, isothermal processes. All thermodynamic processes in which temperature remains constant, means system can exchange heat from the surroundings, and the walls of such systems are conducting walls, hence temperature remains constant. So these kind of processes are isothermal. Second kind of processes in which volume of a process in a process remains constant, then it is said to be isochoric process. Third type of processes in which pressure of the system remains constant. I means during the process, if all those processes, natural processes which are taking place at atmospheric pressure, can said to be isobaric pressure. So isobaric processes have constant pressure throughout the process. Fourth type of processes are adiabatic process. Adiabatic processes are such processes in which the system has actually insulating walls, means heat content of the system remains constant. System can neither lose nor gain heat energy from the surroundings. Heat exchange नहीं होगा उस system का surrounding से. That kind of processes can be adiabatic processes or adiabatic processes. These kind of systems have insulated walls, and the walls are also called adiabatic walls. All the processes which we have discussed in last slide can be carried out in two different ways, and on the basis of the ways by which thermodynamic processes can be carried out are classified as reversible and irreversible processes. A reversible process is a thermodynamic process which is carried out infinitesimally slowly, so that all changes occurring in the direct process can be exactly reversed and the system remains almost in a state of equilibrium with the surroundings at every stage of the process. Means बहुत छोटे छोटे स्टेप्स के थ्रू वो सिस्टम ने चेंज करवाया जाता है, प्रोसेस करवाया जाता है, एंड आफ्टर एवरी स्मॉल स्टेप द सिस्टम अटेन्स इक्विलिब्रियम विद द सराउंडिंग, and hence each step can be reversed back. And actually reversible processes take infinite time for completion, but the work obtained in these processes are maximum. Actually it is only imaginary one and cannot be achieved in actual practice. Naturally जितने भी processes हमारी surroundings में हो रहे हैं वो reversible नहीं होते, because generally natural processes are spontaneous and spontaneous processes cannot be reversed back. Hence it is an imaginary you can say process which cannot be taking place in actual practice. And next is irreversible process. Irreversible process is you can say a thermodynamic process which is carried out rapidly and in such a way that the difference between the driving force and the opposing force, means जिस तरफ आप सिस्टम अपनी फॉरवर्ड डायरेक्शन में प्रोसेस चल रहा है उसका ऑपोजिंग जो फोर्स होगा उन दोनों में बहुत ज्यादा डिफरेंस रहेगा, एंड यू कैन नॉट एग्जैक्टली रिवर्स बैक द प्रोसेस. आप कंडीशंस ऑल्टर भी करोगे तब भी आप उस प्रोसेस को उसी पाथ से वापस रिवर्स नहीं कर पाओगे. तो दीज काइंड ऑफ सिस्टम्स इन विच वी कैन नॉट रिवर्स बैक एनी स्टेज, दैट टाइम द सिस्टम इज प्रोसेस इज कॉल्ड irreversible process, and equilibrium exists only after the completion of the process. Irreversible process में equilibrium हर एक stage के बाद नहीं आता, rather it may achieve only after the completion of the process. Irreversible process takes a finite time for completion, but the work obtained in this process is not maximum as compared to the reversible process. But all the processes taking place in our surroundings are generally irreversible processes. I hope all these basic fundamental terms which are used in thermodynamics are clear to you all. Thank you and have a nice day.